Hello, this is Ralf Stolte. I'm the Sales and Marketing Manager for the Optical Communication Test Equipment with Finisar. We are here at ECOC 2019 in Dublin. I would like to introduce new members of the Finisar WaveAnalyzer family of optical spectrum analyzers. The family has a new introduction, which is the WaveAnalyzer 200 handheld optical instrument, which we see here. And also, Finisar has introduced an L-band version of the WaveAnalyzer 1500 high-resolution optical spectrum analyzer. The WaveAnalyzer 200 is a portable OSA which has a resolution bandwidth of 15 picometers. It has a touchscreen which allows zooming into the signal and analyzing with various analyzing functions. For example, we have one analysis function, which is the wavelength meter function, and that wavelength meter function allows analyzing the wavelength and the power level of a number of channels which are measured by this instrument. We see a number of channels which are listed here on the table with a center frequency and with the power levels. Now I would like to talk about the WaveAnalyzer 1500. This WaveAnalyzer 1500 gets a signal supplied which has been generated by the wave shaper. The wave shaper has an ASE band broadband input signal, plus it has a 10 gig tunable XFP input signal. Both input signals are multiplexed together, as we see it here on this filter trace of the wave shaper. So we have one component that's the tunable XFP, and all the other components are carving out the ASE so that we get a channel-like structure. The result we see here on the top screen. We have all the rounded artificial channels created by the wave shaper, plus we have a real channel which we see clearly different, which has been generated by a tunable XFP. Now we can do some measurements on this signal. And for example, we can look at the polarization properties of the signal, and the WaveAnalyzer allows measuring different polarization components. We see here that the bright red line, which is the total power, and we see smaller signal components which are moving up and down, which are the polarization components which are changing because I'm moving the input fiber inside the WaveAnalyzer. We see that the polarization components change for the tunable XFP, but they do not change for the ASE signal because that signal is unpolarized. Now we would like to look at some additional analysis function here as well. And one analysis we have is the single channel analysis, which also allows doing the OSNR measurement. We look at the 6-point measurement, and that 6-point measurement allows determining the location of the OSNR, of the noise floor, by setting the left and right yellow markers, and then it takes the total power of the channel indicated by this red section, and we see that this channel has an OSNR level of about 32 dB. An additional analysis function which I would like to introduce here is the multi-channel analysis of the WaveAnalyzer 1500S. This analysis function provides the center frequency, the optical signal-to-noise ratio, and the power level of the channels. For example, we see here a number of channels being analyzed, and I can increase the range where the analysis happens. And so we see all the information listed in this table: frequency, power level, and OSNR. The WaveAnalyzer 1500S is available with C-band and with L-band coverage. It provides a unique combination of resolution bandwidth and speed. It provides high resolution 180 MHz at the same time as high measurement speed, update rate up to 10 Hz.